The following video is a tutorial on how to find the remaining trig ratios when you're given one trig ratio. So I'm going to be borrowing, this worksheet is from the Mathematics Vision Project. If you go to mathematicsvisionproject.org and you go to Secondary Math 2 and assignment 6.9, you will find this activity, 6.9. All right, so the directions say, based on the given trigonometric ratio, sketch a triangle and find a possible value for the missing side as well as the other missing trig ratios. Angles A and B are the non-right angles in a right triangle. All right, so we're dealing with all of the trig ratios, so we should probably remember that sine of our angle is opposite over hypotenuse, and cosine of some angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. These are pretty critical, and we can remember all these trig ratios by using this acronym of SOHCAHTOA. SOHCAHTOA. So I'm going to go ahead and I'm going to sketch my right triangle. And it says in the directions that A and B are the non-right angles, so that would be A and B. It doesn't really matter if I switch those. It will matter where I place my 3 and the 4, depending on where my A and B are placed. And then C is my right angle. So tangent of angle A, from this perspective here of this angle, tangent is opposite over adjacent. So opposite of this angle, the opposite side is here, so this is 3. And the adjacent side is next to, well, there's two sides that are next to angle A, and that's this side here and this side here. But this side here, the longer side already has a name. The longest side of a right triangle is called the hypotenuse. So the adjacent side that we're referring to is this side right here. Now we're going to use the Pythagorean theorem to calculate the longest side here. So we're going to use a squared plus b squared equals c squared. I'm going to take my, the c has to be the longest side, so that means that this missing side here is c. So that gives me 4 squared plus 3 squared equals c squared. 4 squared is 16 plus 3 squared, that's 9, equals c squared. I'm going to add this. 16 plus 9 is going to give me 25. 25 equals c squared. Then we're going to take the square root of both sides, and we're going to find that this missing side here is 5. So that means that sine of angle A, which is defined, sine of angle A by definition is opposite over hypotenuse. Sine of angle A is going to be 3 over the hypotenuse, which is opposite the 90 degree, or the longest side, that's 5. So that's going to give me 3 over 5. 3 over 5. Cosine of our angle, of angle A, is adjacent over hypotenuse. So for angle A, adjacent is 4 over the hypotenuse, which is 5. We also have tangent of angle B. Well, we've changed the perspective then of our triangle. We're no longer looking at the triangle from angle A, we're now looking at the triangle from angle B. So tangent is opposite over adjacent. So from this perspective here of angle B, then opposite is going to be 4 over the adjacent 3. So this becomes 4 over 3. Sine of angle B, sine is opposite over hypotenuse. So sine of our angle B is opposite, which is 4 over hypotenuse 5. So I have 4/5. And cosine of angle B from our angle B is adjacent over hypotenuse, so 3 over 5. Let's look at the next one. So we're going to sketch another right triangle. And what we're given is the ratio for sine of angle B. Here's my angle A, B, and C. I'm sorry. It's the directions say that A and B are the non-right triangles, so this is A. B. Sorry, I'm making a few mistakes there. And so we have sine of angle B, which is sine is opposite over hypotenuse. So this is my opposite. 8 is opposite of angle, the opposite side of angle B, which is going to be this side here. This is 8. The hypotenuse is 17. That's the longest side. That's going to be here, so opposite over hypotenuse. Now let's find what tangent of angle A is. Well, we can't find tangent of angle A because from angle A's perspective, opposite would be here over the adjacent 8. I don't have the opposite. So I'm going to find this missing side by using the Pythagorean theorem of a squared plus b squared equals. So we have c has to be the longest side. So the longest side here is 17. So I'm going to write 8 squared plus b squared. A and b don't matter. They're interchangeable. We're just adding anyway. So we could have chosen this side to be a or b. It doesn't really matter. So I have a squared plus b squared equals c squared. And c is going to be our 17 here, 17 squared. And 17 squared is going to give me 17 squared is going to give me 289. 289. And 8 squared is 64. And now we're going to subtract the 64 from both sides to get b squared equals, we're just going to subtract that 64 to get 225. 225. Now we're going to take the square root of both sides. If I take the square root of this 225, I get 15. So the missing side here is 15. So now we can examine our triangle as far as the trigonometric ratios are concerned. So let's write this out again. SOHCAHTOA. So SOHA. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHA, ka, toa. So tangent of angle A is opposite over adjacent, so opposite 15 over adjacent, which would be 8, so 15 over 8. Sine of angle A is opposite over hypotenuse, opposite 15 over hypotenuse, 17, so 15 over 17. Cosine of angle A, or cosine, is opposite adjacent over hypotenuse, so that would be 8 over 15, 8 over 15. Tangent of angle B, we're looking at things from a different perspective now, from angle B. Tangent is opposite over adjacent. From the perspective of angle B, opposite is 8 over adjacent 15, so 8 fifteenths. And then B, cosine of angle B, adjacent over hypotenuse, is 15 over 17. 15 over 17. All right, let's do another one. I'm going to construct my right triangle. This is my A, B, and C. And what's given to me from the perspective of angle A, we have cosine, which is adjacent over hypotenuse. Adjacent, so let's just write this out again. I think that it helps to, as far as directions, if we can remember this, so, ka, toa, then cosine is adjacent over hypotenuse, so that would mean that adjacent is 12, and hypotenuse is 13. And then if we need to find the missing side, we can use the Pythagorean theorem of a squared plus b squared equals c squared. And this missing side here can be a or b, it doesn't really matter, they are interchangeable. The longest side is the necessary part. This has to be, 13 has to be c. I'm just going to call this a this time, so this is side a. This is side A. And that's going to give me 12 squared plus a squared equals 13 squared. Well, 12 squared is 144, and 13 squared is 169. I still have this plus a squared on the left-hand side. I'm going to subtract the 144 from both sides. And that's going to give me a squared equals 169 minus the 144. I'm getting 25. We take the square root of both sides, that gives me that a equals 5. So this side right here is 5. So if I want to find tangent of angle A, tangent is opposite over adjacent, so opposite is 5, adjacent is 12, so 5 twelfths. Sine is opposite over hypotenuse, sine is opposite over hypotenuse, so opposite 5 over 13, 5 over 13. Tangent of angle B, we've changed perspectives. We're looking at the angle from this perspective of B. And tangent is opposite over adjacent, so opposite over adjacent, 12 over 5. So this would be 12 over 5. Sine is opposite over hypotenuse. That would be 12 over 13. 12 over 13. And cosine of angle B would be cosine is adjacent over hypotenuse. That's 5 over 13. 5 over 13. So let's continue. Let's look at the next one. I'm going to construct my right triangle first. This is A, B, and C. And what we're given is sine of angle B, which is 1 over the square root of 2. So sine is opposite over hypotenuse, so that's going to give me, from this perspective here, opposite of angle B is 1, and hypotenuse is the square root of 2. Opposite over hypotenuse. Now, finding the missing side here, remember, finding the missing side, we can use the Pythagorean theorem of a squared plus b squared equals c squared, where c has to be the longest side. So that gives me 1 squared plus b squared equals the square root of 2 squared, which gives me then 1 squared is 1, plus b squared equals the square root of 2 squared, that is just 2. I'm going to subtract 1 from both sides. That gives me that b squared equals 1, and then of course the square root to both sides will give me 1. So this side right here is 1. So if I want to find my trig ratios then, from the perspective of an angle A, my opposite, so opposite over adjacent, that's going to give me 1 over 1, 1 over 1, which is just 1. Sine of angle A, from the perspective of angle A, my sine is opposite over hypotenuse, so that's 1 over the square root of 2. Cosine of angle A is adjacent over hypotenuse, so adjacent, which is 1 over the square root of 2. Cosine of angle B, let's change perspectives. We're from this side. Opposite is 1 over adjacent, which is 1, so I have 1 over 1, which is just 1. Cosine is adjacent over hypotenuse. That's going to give me 1 over the square root of 2. Now, the only thing I don't like about this last problem is that we have a square root in the denominator. And in the United States, a square root in the denominator is never considered simplified. So I would be fine with this, but I really want to write this problem as you would see it simplified in the United States. So 1 over the square root of 2. Again, it's not simplified because there's a square root in the denominator. I'm going to multiply by 1 in the form of the square root of 2 over the square root of 2. That's just 1. Anytime I multiply something by 1, nothing really changes. The quantity doesn't change. So that's going to give me the square root of 2 times, or the square root of 2 over the square root of 2 times the square root of 2, which is just 2. And so I could rewrite these as the square root of 2 over 2 for all of these, square root of 2 over 2. But other than that, this was a great worksheet. I think it really helped illustrate the trigonometric ratios. I hope it was helpful for you, and I hope that you have a wonderful day.